Greetings. I thought it'd be fun today to take some time showing what it's like to play around in an open live software development environment, which happens to be Cuis Smalltalk. What you see at the moment is not a lot. Smalltalk tries to hide complexity by successively revealing things in context. Let's see, but first let me show that just the taskbar here. Just if I put the cursor down here, you see that I can see what's down, and if I click on it, then it comes back up, or I can make it small. Just a way of keeping things tidy. And if I click just about anywhere on the desktop here, I can get the world menu, which allows me to do bunches of things. There's all kinds of help and so forth. And if what I want to do now is to get a new morph. And so a morph is just, morph meaning shape, is just something that knows how to display itself on the screen and react to events and so forth. And if I middle click on the morph, command click, then I get a set of construction handles, the halo, and allow me to do things like clone it, or move it around, or get a menu of things that I can do. And so that allows me to then go from something on the screen to say an object inspector, which says, okay, what's your structure? Let me see inside of you and see what's going on here. And that also has an evaluator here, a workspace. So you can say like self message-based system, color, and it's going to be the color yellow. That's a good one. Okay, and now if I say do it, then you see magically the morph becomes yellow and so forth. So we can go around and look at various bits of business inside the morph. The other thing we want to do is to go ahead and be able to browse the morph class. So this is a class-based system. Smalltalk is Smalltalk defined, object-oriented. And so each class inherits from a superclass and its parent. And it says I'm like my parent except for these differences. And we all know about object-oriented now. And so a label morph has a font, an emphasis, and the contents, which is the label string. And that is a bordered box, which has a border width and a color and a padding, which is a colored box, which has a color, which is a box has an extent and a place has a, layout. So this is just a way of separating out different aspects of objects and being able to go down and just take a look at what are the differences between a colored box and a box, which is, in this case, it's not much. The draw method uses the color when it's showing things and so forth, and you've got setters and a default color and so forth. But let's see, let me go back to label morph here. And I want to open a browser. This is a hierarchy browser, which means it's going back up the inheritance chain. But I want to see for the whole shoot and match here. So this is a regular browser, and again, this is by programmers for programmers. So you want to way to learn your way around the system. And so this browser has a set of categories, which are the class categories. So if we can take a look at morphic kernel, these are the kernel morphs, widgets, and so forth, which has our label. And then there are methods and method categories. So if we take a look at we can go through and see how this thing came to be. And so the method categories then allow you to just sort of group things that are either look at all of them or some group of things that have something to do with each other. And it's just an easy way to find your way around and kind of orient yourself and set things up so when you do something, other people can follow in your footsteps as well. And like everything else that you see on the screen, it's either a morph or composed of morphs. And so you can see this thing, knows how to resize itself and play around and like that. But if you want to go down into the internal structure, you can also command click on this, and every time you command click, you get down to one layer lower in structure, and you can go down to innermost containers and so forth, which means you can also take them out. And as you see, this is live stuff. We're not dealing with dead code. We're dealing with stuff that is alive and continues to work, even if as you're playing with the components. But you can also slice it, dice it, make it run sideways, play around with, what was here and so forth. And as I say, it continues to work. You'll notice that this is anti-alias scaled vector graphics with TrueType fonts and all those sorts of things. So it's, things remain good even under transformation and so forth. So now let me go ahead and, I want to get a workspace up here. And I need all that real estate. I want to give you an idea of scale here. So we do most Smalltalks, say Smalltalk, all classes, size. Oh yeah, we have command completion and syntax highlighting. And you say print it. Okay, so you've got 700 classes, a little over 700 classes in the base image. Cuis Smalltalk has a philosophy and a practice of trying to eliminate everything that is not absolutely required by everyone everywhere. So you want to shrink down code to the simplest form if you can, refactor things to make things simple and comprehensible as much as possible. And when you do that, there are things that frequently you like, but you don't need them every day. So those get squeezed out, and so we have named features which live in packages. And let me go required UI tools. And oops, not UIO, just UI tools. And you notice that when I'm about to tap the close quote on the string, it changes color. I see that. So you see we do have syntax highlighting, which is helpful. And if we say do it, again, Command D will do it. Now it's going to load in a bunch of things. And the reason is the system, to avoid library hell when you don't know what's going on here, is to, well, let me just show you the package editor here. You can go through and you see the UI tools package has a number of requirements. And so the idea is that you want to say, okay, to be successful, these are the requirements that I have, and I require at least these versions. So I require versions in this range, and these are the packages I require. Okay, and so the system goes through and says, okay, let's find all these things. If I can't find one, I raise my hand. If I find the requirements and their package is fine, then I look in that package and see what requirements it might have and check everything out. And assuming everything works, then you just auto load everything in the right order, and you don't have to worry about having your package there, because everything you need to be successful should be there. And if you bring in something new that you now require, you can add a requirement. And I'm not going to do this, but I'll just sort of fake it here. So I can say, okay, I need to add this click select thing, and oh, the palette, that was an older version there. If I do an update, then now suddenly you see it's been updated to the current version. And then this tells me that I've made a change here. And if I do a save, then this package will now be saved with these newer requirements, and it will require some of the newer things. So as time goes forward and things change in the system, you have a way of evolving together and dealing with that, and not having your shoes tied together with the wrong, trying to find what version works with what and all that kind of stuff, which is really painful. So we decided we wanted to avoid that. So let me go ahead, and I want to do this again, but I'm just going to go ahead and copy that, and paste it, and now print that. And so now we see we've got almost 900 classes. So again, the Cuis Smalltalk uses the open Smalltalk virtual machine. There are two other Smalltalks for comparison that use the same VM. One is Squeak, and Squeak in their base image usually has on the order of around 3,000 classes. And there is Pharaoh Smalltalk, which has on the order of 10,000 classes. Now, all this code does some stuff, and I'm sure it does nice stuff, but the Cuis philosophy is you want to have a smaller basis to be able to go in and learn, and then when you bring in some new feature, then then you can take a look at the delta, the code that's different, and you just have to understand that delta, and that helps keep the system more comprehensible to us mere mortals. And so we're doing things by programmers for programmers, so it helps us out. That's typical of Smalltalks. Okay, so let me bring up a menu for this guy, and I'm going to hit the push pin to keep that around. And now you notice there's some new, when I brought in UI tools, I brought in some extra functionality, and we've got things that are different here. And so if I want to change the contents, I can say, oh yeah, you want to see this stuff, you want to get it, https cuis.st for Cuis Smalltalk, and we get the new label for new menu for this guy, and I want to make that yellow as well, so I can just drag and drop. That helps. And actually, I want to go ahead and let's see. Oh yeah, this is Cuis Smalltalk, so I should say that. And that's not really very readable, so let me go ahead and, again, true type fonts. So we can go ahead and make it a little more readable there, and as a matter of fact, I can drag and drop other values, and so you see that that this allows you to just sort of easy peasy make changes to these things. And oh yeah, as long as I'm doing this, I probably, let me clone this, should say who I am, because I sometimes forget to say such things. And so single click, I usually get an editor. So I am Ken Dickey, and let's give me a different, let's see, that's fine. And maybe I'll make that bold. Okay, and we'll accept that. Now, when you start getting multiple menus up here, it can be confusing about who goes with what. So I can say show my Morse Halo, okay, and that gives me the construction handles. So this is the Halo construction handles. And so it makes it easy to know which particular menu is attached to what particular morph when you're doing things. And so that allows you to get through and do some fun things. So if I, let me just start exploring here a little bit. Let's see. Let me give myself a border width, make something we can see. So 12. So now we've got a border. And color in computers is interesting. There's a big science of color and color models and color perception and so forth. And Cuis has pretty good support for a lot of this stuff. So there's different name value dictionaries that have been done. So if you want crayon colors or XKCD or CSS3 web colors and whatever, you can go through and get a color dictionary and and that'll give you a color picker. And let's make this, a little, pardon me, got different color dictionaries there. I make this a little larger. Okay, and And so the tooltip gives you the actual color for this. So I can make that border color turquoise and so forth. So anyway, that for me, in terms of nomenclature, this is a color picker, a palette that I can pick colors from and then drop them. And then there are things that are color editors that some people call color pickers, but I don't think that's the case. And so here, if I bring up a color editor, for me is something I can start with a color and then edit it. And so here we've got a color cube that, in this case, the axes are red and blue, and then there's a slice through the cube. So we get a 2D slice through a 3D cube, and that's what this little elevator is for. And we can change the axis. So now we have red and green are the X and Y axes, and this is the blue slice through the cube. And so, you know, we got the typical color editor type things. And then we also have multiple models. So HSB is, again, an older color model supported in CSS3, I think it is, that where hue, let's see, wait a minute, let me get it more saturated. There, that's better. So hue gives you the base color. That's the color wheel, gives you the 360-degree, color wheel there. The saturation, obviously, is from highly saturated down to gray. And then brightness, which gives you the amount of lightness. So you go basically white to black to separate that. So again, this is a cube. It's got the 3 dimensions, and you're able to go through and, and select what, we need something that's, here we are. Give me a hue. The thing is, RGB, when you want a color like golden yellow or whatever, RGB, the colors don't necessarily pop. The RGB colors don't just pop into your brain. But HSV, you can go through and say, oh yeah, I want some kind of a yellow, and then I want to go ahead and change the saturation and make it a little more highly saturated or whatever, and then maybe change the opacity, give it more alpha, and so I can have the color with the alpha, I can have the fully saturated color, or I can have the closest CSS3 named web color, and that sort of thing. And so if I just take that, I can just drop that over here and see what that particular thing is like. And so that gives me a place to hang my hat. There is a disadvantage, though, however, with the HSB color model, and that is it's not perceptually uniform. And by that, what I mean is that when I go up here, you see there are certain colors that are, to our eye, are seen as highly saturated, okay? Now, I'm not changing the saturation over here. I'm just changing the hue, the base color, okay? So, and then as I move this along, you see some colors are are very saturated, and some colors just are not nearly, to our eyes, they're not nearly, that doesn't look as saturated to me as this does, okay? So our perception are non-uniform. And where this shows up is when you want to make palettes of colors. And so let me show you something here. Get that small for the moment. Okay, so people have done things. There's a newer model called the OK model. It's not perfect, but it's OK. OK, LCH for luminance, chroma, hue, and so you can get tools that are kind of like this. The idea is you want to make a color palette that allows you to do a range of colors that maybe even dynamically, where you can see, for example, text against all these backgrounds. So whether something's forward background, highlighted, not highlighted, it's a button, whatever it happens to be, you have a set of colors that have similar perceptual values. And so in this case, each row is has a hue, the same hue. So red, mustard, turquoise, fuchsia, whatever. It's the same hue along here. From left to right, each column has the same brightness, so goes from light to dark. And they also have, each column has the same chroma value. So in this case, the amount of saturation. So in this case, between rows, the saturation is different, but each row has the same saturation. And you can make rules so you can know that when you need to invert colors or something to make sure some text is readable, it's easy to do that. So that's the goal, is to have uniform perception of colors. There's a downside, however, to the OK model. And the downside is that it's not a cube. It's not a color cube. And so you see this because with the values of the HSV have been, if you will, stretched to make it so a cube, so that in each of the 3 dimensions, you always have a color that the monitor can generate at that particular spot in the cube. But here, because the color perception is to be uniform, there are places the monitor doesn't generate colors that our eyes can perceive in a useful way, or that the monitors just don't do that there. So there's a lot of space here that's invalid in terms of a 3D cube. And how this shows up is if I change the lightness, you can see how with regular sliders, you see the chroma changes quite a bit. And when I change the chroma around, you can see we can get into areas where there's just no color present that the monitor can put out at some values. And so the way of doing the 3D slider for a cube makes less sense for the OK LCH model. So now let's take a look at my reaction to that. Pardon me. So my reaction to that, let's get a different editor. And this is the OK LCH editor. And we'll take a look here. And so my idea was to just use the color wheel and then take a slice through the cylinder where you have the color wheel, and then you can change the lightness around, and that does make a difference, the area which is valid for monitors. And then the radius in this case is the chroma. So it goes everything from gray to more fully saturated. And if you have things around the clock here at the same chroma, and then you see that the color perception is basically uniform. So I can go around the wheel and I get all kinds of colors, all kinds of hues, but the hue and saturation perceptually is uniform. So that's the advantage of this particular model. And then, we can go around and get more highly saturated colors. And actually, let's see, let me go ahead and give some alpha here too. 40%. Okay. So, since we have drag and drop here, we can see what this looks like in different models. So we can look at HSV and look at the values. We can look at the RGB and see where it is. And you see the hex RGB. The RGB value is the same in both of these. But with drag and drop, it's easy to do this sort of thing and to be able to make changes to the values around here. And again, we can pick some color down here, and I don't know. Yeah, but tomato. Okay, take a look at tomato, and take a look and see what this is like in one of the different color models and how they relate to each other. Anyway, so that's I guess the majority of it. Just trying to take the walls down and make things a little more uniform and easier to deal with. And then again, how things are set up and how things are composed. Once you know you can get to the code, you can also, pull things out and play around to see how you want to set things up. So there are layouts that lay things out in a row or a column. So if we say edit me, okay, let me go ahead. So here we have a layout, and this is a column, but I want to make that into a row. And I say, okay, we'll update that, make it into a row. And now I can, play around, resize things here. And you see that things are laid out as a row. And then you can drill down and say, well, within this row, I've got 3 areas, and each of those areas has a different layout. So this is a column within a row and so forth. So it's just kind of an easier way to figure out what's going on there. And again, if we go ahead and take a look at the code behind this, let's see, browse the morph class. So this is the OK LCH edit panel, and initialize goes ahead and builds some basic morphs, and then we have a build morphic window routine, which is then push those into their places so you can see how you do the compose layouts and put things together and so forth. And each of those things, the lightness slider and whatnot, you can then pick your way around here, see how things are put together, and again, go from having to just tweak knobs that somebody else has put together to having an idea and making your own knobs to tweak, so to speak, and so forth. Let's see, what else should I say? Yeah, there is a bunch of help. Okay, so terse guide. Again, terse guide is not something everybody needs every day, but it's nice to have samples. So you've got Smalltalk syntax. It basically fits on a postcard. You go through and take a look at strings and symbols and sets and dictionaries and date and time, whatever it is, and you've got a whole bunch of sample code, and this is all live, which means you can go through here and you can execute, you can evaluate any of these things, and that's live, and you can get from here to there. So, oh yeah, and there's a foreign function interface, so you can call C code and so forth, and let's see, what else? True type, Unicode, scalable vector graphics, easy to find your way around the system. The syntax is fairly trivial. And oh yeah, again, the Open Smalltalk virtual machine, this happens to be a Mac, but I can save this image on the Mac and I can bring it over to a Windows machine or a Linux machine or an OpenBSD machine or whatever, and it'll come up, and modulo the screen size, you get the same windows, the same morphs, in the same positions, pixel per pixel. Okay? No recompiling. You just take the image. You have a virtual machine for the OS you're running on, and it comes up again. The Open Smalltalk virtual machine defines portable. So that's what portable means to me. Is I can take this image, I can save it here, I can bring it up on a RISC-V or an ARM or an Intel machine of most of your major operating systems, and everything just works, and everything looks the same. As I say, the same windows in the same positions, pixel per pixel. So that's it. Basic intro and just kind of fun stuff. And I recommend Cuis. You ought to go there and find out about it. It's a lot of fun to play with.